Hi everyone, my name is John Lund. I'm a professor of electrical engineering at Western Washington University. And the purpose of this video as part of Admitted Student Days is to give you an overview of the electrical engineering program at Western. It's really meant to sort of give you an idea of what you can expect if you come to Western. It's not really so much meant to be a sales presentation. It's really more just to give you as much information as possible so you can make the decision that's right for you. What are we going over in this presentation? Well, the biggest thing is most of you are looking at Western, looking at this Admitted Student Day video and trying to decide what school is right for you. And so we know you're comparing lots of different schools, so we want you to know what's different about Western's electrical engineering program. Or maybe you've decided to go, you're gonna go to Western, but you're considering what sort of concentrations of electrical engineering to go into, or you just kind of want to have a good idea of what you can expect, already knowing you're going to be in the program, or maybe you're kind of deciding between two majors at Western and you're trying to see if electrical engineering is the right one for you. So this video should mostly cover, should help answer a lot of those questions. So we're going to start by talking about what is electrical engineering. So just sort of, just to give an overview of the field. A lot of people have a lot of different ideas about electrical engineering, and that's because it is such a big field. It encompasses a lot of different things. And my relatives, a lot of times they'll call me and they'll say, "Hey, John, can you help me wire a three-way switch?" And I'll say, "I'm not an electrician." And they'll say, "That's not what I was told." So sometimes some misunderstanding as to the nature of electrical engineering persists. So we're going to try to clear that up and just give a brief overview of what electrical engineering is. So what is it? So electrical engineering uses fundamental principles of electricity, electrons, and electromagnetism to design things that solve problems. So electrical engineering is not really a science. Sciences sort of develop fundamental understandings of the universe. Engineering sort of applies those fundamental understandings in order to solve problems. And so electrical engineering is solving problems, specifically solving problems using the principles of electricity, electrons, and magnetism. EE is a really important area in addressing a lot of challenges that we face. It's a big part of healthcare, energy and sustainability, and sort of the smart and connected world, sort of these sort of future-looking goals. So to add to that point, if you look back at the listing of greatest achievements of the 20th century, as published by the National Academy of Engineering, a lot of these are electrical engineering categories. So a lot of these, in the past century, things like electrification, electronics, radio, computers, telephone, the internet, imaging, laser and fiber optics, a lot of these sort of grand revolutions came out of the field of electrical engineering. And there's the thought also electrical engineering, looking forward to the next 100 years will also be a pretty big part of that 100 years as well. And you can see that on the right side of this screen in the context of these kind of grand challenges. So electrical engineering has played a big part in the engineering discipline and in society at large, and it is anticipated to continue to play a pretty big part. So what's different about Western's electrical engineering program? So a few things are different. One, Western is primarily a teaching school. So currently we do not have a graduate program in the electrical engineering area. And what that means for the most part is that faculty have an emphasis on teaching. So our primary objective, our primary task is teaching, is achieving good undergraduate outcomes. That's different than some schools. Some schools are primarily research institutions where you have a lot of faculty who focus less per faculty on teaching. That's not necessarily bad, it's just a different way of doing it. So an undergraduate program is going to have faculty mostly devoted to teaching. Research programs are typically going to have faculty mostly devoted to research that also teach a couple of classes. There is a trade-off, right? So the trade-off is a lot of the big research institutions are doing a lot of cutting-edge research, and so the person teaching your class will be somebody who's sort of at this cutting edge of modern research. Now, there's a lot of good research that goes on at Western as well, but it does primarily focus on teaching. And what that means is, for a student, is you have much more access to the faculty that are here. So one of the biggest things students will note to me when they've gone somewhere else after leaving Western, or when they've come from somewhere else, is that they're surprised by the amount of access they have to faculty. They'll go somewhere else and they'll say, "I didn't realize that at most places, you can't just stop by your professor's office, and if their door is open, you can stop and have a conversation with them. You know, other places sometimes strictly limit students to office hours. Western typically has a lot more faculty access. Western's also, our program is project focused. So the program culminates in a final senior design project. That's not uncommon for electrical engineering programs. One thing is we do have a full year project component. So, and we also complete almost all of the core program curriculum before getting there. So by the time students start their senior year, they've really gotten the entire background of the electrical engineering curriculum, and they focus that full year on doing a really meaningful final project task. And so that's led to some really great resulting student research projects. And then we also are cohort based. So currently we're cohort based, which means that our curriculum follows a typical path of what you'd see in high school, where you start with a class with a cohort of students, and you're with that same cohort of students throughout the entire degree. So you're each taking the same classes year after year within the program until you graduate. And so the benefit of that is you sort of have a community, you have, you know, people that you meet your freshman year, you're gonna stay in the same classes with them until you graduate. The downside is that means that you're on rails. So when you come into the program, you're basically starting, and it's really important to keep up with the program, to pass your classes, take the classes that you need in sequence, and stay with that cohort. Because if you fail a class, and that class is a required prerequisite for another, which most of ours are, it means that a lot of times, instead of just failing a class and taking it the next quarter, you're taking it the following year. So it can bump you back a year. That doesn't happen that often, but it is something to keep in mind. So what is electrical engineering at Western Washington University like? What could you expect if you're a student coming in here on the first day? Well, one thing to note about our program is it is ABET accredited, and that's very important, especially for employers. So employers, a lot of times, they don't know necessarily the details of the curriculum of every school that's out there. They're not going to watch this video, for instance, for every school that one of their potential employees might be from, but they understand what ABET accreditation means. And I'm going to show you the ABET accreditation slide a little bit later, but that basically means that Western sort of meets this sort of core meat and potatoes requirement for an electrical engineering program. We also have 7 full-time faculty. We have 1 new additional faculty who's going to be joining us next year, and we are searching for 2 more faculty right now. But that's about our faculty size. And we recently increased our enrollment to 40 students admitted per year. Our class sizes range from 8 to 36 students, so we've worked really hard to try to keep our class sizes small. The majority of the class sizes that you will experience if you're watching this video are going to be under 24 students. So we're really trying to make sure that our classes don't get unreasonably large here at Western. We also work really hard to maintain modern teaching facilities with modern laboratory equipment. So from the first day you arrive, we try to make sure you're using similar tools to what you'd experience if you worked for a company. And that usually means industry grade equipment that's a little bit more expensive. That means lab fees are a little bit more expensive, but that's mostly what those pay. It's almost all of what those pay for. Lab fees that we have cover the cost of maintaining modern equipment. And so what you'll see in the labs is the same equipment you'd see working in industry or working in research laboratories. We've also seen rapid growth in the electrical engineering program. So over the past, basically ever since we switched from engineering technology to electrical engineering, we've seen a lot of interest in the program. And so we also expect to continue to see that. And as part of dealing with that, we have received a commitment for funding from the state to build a new building. The current timeline shows that if you're watching this video, the current timeline would say your senior year, you would be moving into that new building for a senior project. That's the current timeline, though. Obviously, things change, things come up. But the way the current timeline is set, students watching this video who would be potentially enrolling in this fall 2020, would their senior year start in the new building. So this is taken from the ABET website. So I just sort of screen captured the ABET website. Hopefully you can see the web address there. This basically shows the outcomes for an ABET accredited electrical engineering program. So there's 7 of them now. And these are what ABET looks at for any electrical engineering program to say, if you're accredited, you're going to meet all 7 of these required outcomes, meaning that when students leave your doors after a degree, they will have all of these. So they will have an ability to identify, formulate, and solve complex engineering problems, an ability to apply engineering design to produce solutions that meet specific needs, an ability to communicate with a range of audiences, an ability to recognize ethical professional responsibilities, etc. So all of these are really good to look at. I think they're important to look over. These are also important because the courses that we teach all ultimately sort of tie back into these core outcome requirements. So it's sometimes interesting to see, for instance, as your classes go from freshman classes to senior classes, they shift more and more towards these sort of ability to sort of apply engineering tools to solve problems and things like that. They sort of shift from acquiring knowledge to applying that knowledge to solve problems. Okay, so what's it like to be a student at Western Washington University? So what I'm going to do in this is sort of take you through each year of the program, what you would experience. So what you'd experience your first year, your second year, your third year. But I also want to mention that the big thing here is your experience is going to be different depending on which concentration you choose. We have 2 concentrations. We have the electronics concentration and the energy concentration. Now, as we talk about these, keep in mind that 80% of the 70 to 80% of the curriculum is the same for both of these programs. So there's not that much of a difference in your experience between these 2 different concentrations, but there is some, and we'll go over that. So for the electronics concentration, what do electronics concentration students do? Electronic concentration students mostly focus on developing, designing, engineering embedded systems. So these are devices that typically they are devices that operate without much human interaction. And sometimes that's a bigger challenge than devices that operate with human interaction. For instance, I have this example photo here of these Amazon buttons. These little, I don't know if you've seen these. They're basically, you put a little Tide one on your dishwasher and you push a button, and then 3 days later you have Tide laundry detergent show up at your door. These things have a very simple operation. Push a button, get Tide laundry detergent. But behind the scenes, there's a very complex technology that's required to make that actually happen. So you have inside of each one of these, you have basically a microcontroller, which is a computer connected to a radio module. So it needs to basically set up established communication, verify the order, things like that. So all of these different things, there's increasingly with embedded systems and electronics, a lot of design that happens inside of devices that users don't necessarily see. So there's a lot of this underlying technology design, and that's a big part of what we focus on in the electronics concentration. So we're building things faster, smaller, and cheaper. So we're using low-cost radios, low-cost microcontrollers, and together those sort of become what people call the Internet of Things, this idea of having sort of ubiquitous devices connected to devices connected to the internet, able to solve problems that people normally didn't even think of as things that could be solved by a computer system. Things like ordering laundry detergent, things like that. These are devices that are smart, they're low cost, they interact with their environment, they have sensors on them, they have sometimes output devices, they make decisions sometimes. And with these new devices, there's challenges that we solve too. Challenges with ubiquity, challenges with security, and challenges of integration with machine learning and artificial intelligence. So in addition to the electronics concentration, there's the energy concentration. The energy concentration looks at sort of how do we solve problems that are related to the expansion of renewable energy, and how do we solve problems that are related to the sort of shifting model of energy production and energy delivery and energy transfer. So as we move more towards smart grids, as we have more and more devices that are putting energy on the grid, we start to have more and more challenges, and those challenges require better modeling of grids, better development of energy conversion technologies, better development of decision-making technologies, of rapid monitoring and protection technologies. The old model for power grids was you have a power generation facility at one side of, hopefully the side of the city where not too many people live. You have a coal plant, and it produces energy, and then it puts that energy on a transmission line, and the transmission line moves to distribution lines, and then those go to neighborhoods. Well, increasingly, we're starting to have power coming from all over the place, right? You might have, if you have in your neighborhood a lot of people with solar panels on their house, you know, from 10 a.m. until 5 p.m., they might be producing a lot of energy. And if you have an electric car, from 6 p.m. until midnight, you might be consuming a massive amount of energy. And these changes to the sort of usage of energy and where energy is produced and where energy is consumed, these changes produce a lot of challenging problems. And the energy concentration is in large part dedicated to producing students who, when they leave Western, are able to help contribute to solving these sorts of problems. So the faculty that we have, I mentioned we have 7 faculty. So here they are listed by their area of expertise. Under circuits, you have Professor Todd Morton, myself, Professor Steve Sandelin. Power and energy, you have Shichen Zhang, Amar Radwan. And signal processing and communications, you have Ying Lin and Professor Andy Klein. So all of these faculty, you know, these are sort of their core areas, but some of us sort of have operate in a couple different domains. Please feel free, I'll show a contact screen later, but feel free to contact any of us with questions you might have about these specific areas or interests you might have related to these specific areas. So what's the first year like? Your first year at Western is mostly going to be taking care of prerequisites. So it's going to be getting your math done, getting your physics done, computer science courses done. It's also going to be taking the sort of broad courses that you take as part of any undergraduate degree: humanities, social sciences, and the arts. At Western, we call those GURs, general undergraduate requirements. And you will take a couple of electrical engineering courses the first year. You'll take EECE 108, 109, which is Introduction to Electrical Engineering. It's kind of it's a 2-credit class, but it's really kind of it gives you an introduction to what the program is. Not all the students in the program are going to be watching this video, for instance. It gives you an introduction to what the program is. It gives you lab experience. You get to build something. You get to build something and optimize it and compete. It's a fun class, and students tend to appreciate it. It's a nice transition into that kind of classroom laboratory setting. And then there's also EECE 111. That is the first circuits class. So that is Circuit Analysis 1. So I've taught that for the past few years. And that's sort of your you know, Circuits 101. It's not actually 101, but it's basically that introduction to circuits, analyzing, constructing, and testing simple DC circuits. And after that first year, that's usually when you would apply for entrance into the program. And then you'd move on to the second year. But we also really encourage students in their first year to get involved in other ways. Students are more successful in the program and at the university if they have some connection to the university that's not just work. So being involved in student groups, in volunteer groups, in athletic groups, these all really help students succeed. So some programs really encourage students not to do any kind of other activities. But we found that quite often those can help students have sort of a reason to persist in the program if they have sort of something else that's tying them to campus other than just the work that happens in the curriculum. So that's the first year. So the first year, after the first year, you would apply to be in the major. And then, the second and third year. This is a lot. There's a lot of courses you take in years 2 and 3. These are just the core courses. So these are courses that students would take if they were electronics concentration or energy concentration. Everybody takes these classes, and we understand there are a lot, and that's a big difference between our program and some others. We have a lot of curricular courses. It is a big course load. It does require full-time dedication to the program of study, but on the flip side, you get a lot of coverage. So when you leave Western with an electrical engineering degree, you've taken a lot of classes that have given you a lot of expertise in a lot of different areas of electrical engineering. So this is in years 2 and 3, these are the courses that are shared. These are the courses that are not shared. So we have 5 electronics courses and 5 energy courses that are specific to those concentrations. You can see them here. And I'd also encourage you to go to the link at the bottom of this page, which will give you more information about these courses. I'm gonna quickly show you something that you can get following this link that I find useful, the flow charts, but let's that's the gist of it. So, so year 4 is your senior project. And again, we try to have all of your core coursework done before the 4th year. There is a couple classes you still take the 4th year, but almost all of it's done by the 4th year. And so this is a year-long sequence. The first quarter is project planning, research, background research, development, implementation. The first year is project planning, preparation. The second quarter is hardware that we do. So the second quarter of the senior capstone project is hardware. And then the third quarter is software. So it's kind of and actually it's a little different for the energy students, but it basically follows that flow. You go through a similar experience to what you would have working on a design project for a company, where you start by examining existing designs or potentially reverse engineering existing designs. You then come up with a proposal for what your design is going to be. You identify user requirements, technical requirements. You then develop a design for your system based on those requirements, and then you end up for the energy students, you don't necessarily have the same software component, but you always end up sort of having a finished implementation by the end of the year, by the end of your senior year. So a lot of these senior projects instills some of these skills that are hard to teach in the rest of the curriculum: teamwork, communication, project management. Many of them are also sponsored by companies. So right now, students have a lot of flexibility in terms of where their project comes from. A lot of them will choose projects that are sponsored by companies or projects that are related to companies. And a lot of times it's companies that they're hoping to work for. And we've had a lot of students work on a project with a company, it goes really well, then they end up working for the company, and that's been a really good model for a lot of students. It works pretty well. So this is pulled directly from our website. It's sort of one click deep from the link that I showed earlier. This is the flow chart for the electronics concentration. So this shows all of the courses that I showed previously. This shows them in a format that just kind of shows what area the course is in and what its dependencies are. So you can see here what courses you have to take, what prerequisites you have to take before you're able to take a course. And you can see from these arrows that it's basically a continuous stream of courses from the fall, from your first year until the end of year 4. And a big thing to get from this is it sort of shows you have to pass each class in order to keep up in the program. Basically, there's very few classes in this spreadsheet where if you had to take them a year later, you would be able to not sort of miss taking a class that's dependent on that. There's a few of them, but not much. So this is a really handy tool. I've always found this to be one of the best ways to sort of show how the curriculum moves as students move through the freshman to senior year of the program. Here's the same spreadsheet for the energy concentration. So hopefully you can see that web address up at the top too. But if not, you can go back to the link that I showed earlier, and it's the flow chart is 2 sublinks on that page that I linked to earlier. So what are the outcomes for our students? This is usually for this presentation what students and their parents are most interested in is, what do I get when I leave? What do I get after 4 years if I stick with it and finish the program? Well, we have over a 90% success rate in post-graduation outcomes, meaning students quickly getting a degree in their, or getting a job in their field of interest, or moving on to graduate school. We have a lot of students who go work for companies, a lot of students who go work for local companies, Microsoft, PACCAR, Fluke, PSE, Alpha Technologies. These are all common employers of our students after they graduate. These are all local Washington employers of our students after they graduate. And the national salary for EE students is about $74,000 coming fresh out of undergraduate degree. And that's been fairly standard. From the students I've talked to who come to me and say, here's a job offer I had, that's been pretty ballpark. That's usually where I'll tell, I'll say, well, that seems like a pretty reasonable sort of salary offer. Okay, so questions. If you have questions, I believe there's a live question and answer session being hosted by Professor Zhang. I'm not quite sure when that is going to be. I'm sort of doing this sort of offline video, but he should be available to answer questions live for you. You can also feel free to contact me. My email address is john.lund@wwu.edu, or contact any of the faculty. So here is a page taken from Hopefully the web address is visible up there at the top, but this shows sort of all of our faculty, their contact information. And you can go back and see sort of what areas these faculty were each in, to sort of pick one if you want to talk to somebody who specifically has research areas or specialization areas that are related to what you're interested in. So I've done this presentation several times. It's usually live. This is the first time I've done a video, but every time I do it, I get questions from people. They're good questions, and I'm gonna try to kind of answer the questions that people tend to have. The questions that these sessions people tend to have are related to jobs, and before that related to internships. So one question students or their parents typically have is, are internships part of the program? In our program, they are not integrated into the curriculum. So some schools have an internship sort of usually between the sophomore and junior, or the junior and senior year, a summer internship. And they sort of have that internship be part of the sort of overall degree process. It's a mandatory internship. We do not have mandatory internships. We do not have placed internships. However, for our students who are interested in pursuing an internship over the summer, our students have a very high success rate. So the vast majority of students who want an internship over the summer have been able to find one in their field. Job placement, as mentioned on the previous slide, we have over 90%. It kind of varies from year to year, but it's definitely over 90% success rate after graduation. We do not. Western has some resources for finding a job. We do not specifically sort of tie students to particular companies, and so we don't kind of help that transition to the job, but our students have been very successful in finding jobs. So those are kind of the questions people tend to have after this presentation. But again, if you have more, feel free to talk to Shi-Chen in that live session, or send an email to myself or any of the other faculty. All right, and that does it for the presentation. Thank you for watching. Hopefully it worked out all right. It's a little weird doing the video format, but I appreciate your time, and I hope to see you sometime.